Okay, good morning. Welcome to
FamilyMath974.
FamilyMath974. So today we're going to look at a shape called the Permutahedron. This one, which we'll look at, it's because it's a little bit bigger, is unfortunately broken. But this is a new one that we 3D printed this week. Let's try to get that on camera real well. And I would like you to probably keep it right where it is, but you can move it around and tell me what you see. What do you think this shape is about?
Well, definitely seems to be
Move it down a little.
here.
Yeah, I'll put the
interesting
eraser there.
thing about this one is that, like most shapes that we look at, don't have any. Most of the edges are just like, sort of like this, but this shape has like edges that are completely flat, like edges that come together to form one edge, and we don't really see that much. Like
I'm not sure what you mean. Tell me what you mean by that.
So on this big edge here, there are these edges crossing it to make these smaller faces.
I see. Okay. Yeah, and that's interesting. So here we have some edges that cross each other, and that certainly also makes a neat shape. That's true.
Let's see, what else? Looks like we do have a bit of maybe threefold symmetry. We've got this same shape over here and over here and up here, but it's different down here, which is interesting.
You want to talk about this, what you see in this shape? But why don't you, let's take this away, why don't you talk about the bigger one, even though it's broken, and we'll try to zoom out just a tad.
Alright,
and I'll do the same thing, kind of with the eraser.
well, you can kind of get it to, like,
Yeah.
it looks like kind of all the vertices are connected to the one opposite it, and you can get these interior lines to sort of line up like that.
Oh, that's cool.
Maybe like that. Yeah.
Oh, neat. It's actually funny where I'm sitting. It looks very different.
Yeah.
Okay, so what does that tell you about this shape?
It's got some symmetry, and I mean from the top and bottom it looks like threefold is kind of the way to go. But what's interesting about it is that you have these pairs of triangle faces, or kind of truncated triangle faces. This one's here. I don't know how well it shows up, but this face here and this face here are paired. But this one's bigger.
Oh, okay. So the designer of this shape and got it off of Thingiverse, so I'll probably put it in the blog who the designer is. Yeah, made the opposite sort of hexagons, different sizes.
Yep.
Do you have any idea what this shape is, other than being named a Permutahedron?
Well, a permutation is like taking a set of things and then ordering them differently. So maybe it has something to do with like ordered pairs. And if you rearrange the ordering of the pairs, it makes a different vertex. And then maybe they're connected up somehow.
Okay. Do you know how many vertices we have here?
Let's see, we've got 6 on the top, another 6, and looks like another layer of 1, 2, 3, 4, 5, 6, and then the 6 on the bottom, so it looks like 24.
Okay. What would that suggest to you as being permuted?
Instead of 4
Four
elements.
things, yeah.
This is 4 times 3 times 2 times 1.
Okay. So we have here possibly something relating to the permutation of just this simple set 1, 2, 3, 4.
Yeah.
Any surprises that this is a permutation of 4 sets?
Well, we're only in 3 dimensions, so... And if there's 4 coordinates, then I'm puzzled on how that works. Maybe one of them is excluded somehow.
Interesting. Anything else you want to say?
No, not really. It's an interesting geometric shape. That
It's got...
not sure how it relates to permutations of 4.
Okay, yeah. So what I'm going to do is I'm going to have you both read the Wikipedia page now about the Permutahedron.
Alright.
Actually, I haven't even looked at it. I don't know what it says. So hopefully it exists, and then we'll talk about that page.
All right.
Alright.